This is section 2.7, inverse functions. I actually made a mistake when I was typing this up. I plan to fix it so that you will have a corrected copy available to you. But by definition, inverse functions. If f and g are two functions such that when I compose f and g, so when I take g and plug it into f, I get x. So whatever I plugged in here, I plug it into g, take that answer, plug it into f, and I need to get back to x. For every x that I'm allowed to plug into g. And then the same thing happens if I reverse this. So if I take the x value and plug it into f, get that answer, and then plug it into g, I should get x. Basically what this is saying is that inverse functions undo each other. Okay, we talked a little bit about this when we were talking about a general quadratic equation or quadratic function versus a square root function, how they looked very similar, like one was on the side, how our x's and y's got flipped. We talked about the same thing when we were talking about a general cubic function versus the cube root function. Okay, those are examples of inverse functions. Okay, so basically what this is saying is that there is an inverse function such that if we can take an x, plug it into the inverse, this is red f inverse, not f to the negative 1 power. Okay. Then it's we plug in x into this, take that answer, we should get x back. They completely undo each other. All right, so the domain of f is equal to the range of f inverse. The range of the domain of f inverse is the range of f. They just go back and forth, back and forth. First couple of problems. They want us to verify that the two functions they give us are inverses. So that means we need to do two things. The first thing we need to do is to find f of g of x, and we hope that when we do that, we get x. And then if that works, then we have to do the other way, g of f of x. And we should get x. If we get x going in both directions, then they are inverses. If we don't get x going both directions, then they're not inverses. Okay? So let's try this one first. F of g of x is x over 6. Now take x over 6 and plug it in here. This is 6 times x, but instead of x, I write x over 6. Well, that's 6 over 1. Those 6's cancel, and I get x. So this works in that direction. Now let's try this one. G of f of x, and f of x is 6x. So I take 6x and plug it into g, so this will be 6x over 6. The 6's cancel, and I get x again. So this checked out both ways. So this one, they are inverses. Okay. Let's try this one. Again, I want to do the same two calculations. Let's find f of g of x. Well, this will be f of 2 over x plus 5. So this is, I take all of this and plug it in for x right here. So this is 2 over x plus 5 minus 5. Don't lose this part when you're plugging it back in. It's very easy to mistake to make. Now what happens here? Our 5's cancel out. So right now I have 2 over x. I'm going to multiply top and bottom here by an x to make this go away. So this is x over 1 down here. Those are going to cancel. So when I do that, I get 2x over 2, which is x. So it does work in that first direction. Now let's go the other way. G of f of x. So this is g of 2 over x minus 5. Okay. So that means I'm going to take 2 over x minus 5 and plug it in right here. Now this is going to get pretty ugly. I'm going to kind of go off and scratch paper and figure out what 2 divided by, that's 2 divided by, right? 2 over x minus 5. So I'm basically just going to calculate this little part right here, plugging this into here. Okay, so this is over 1. This will be the same thing as 2 over 1 times, do the reciprocal of this, x minus 5 over 2. And so these 2's cancel out. So when I plug into just this part, I get x minus 5. Okay, so I'm actually going to write this all out right here so you can see what's happening. But this is my calculations over here. So this is 2 over x minus 5 plus 5. Now we just calculated this part, that's right here. So this is x minus 5 plus 5, which gives me x. These calculations are not always pretty. In fact, they're often not pretty, but you should get x going both directions. Okay. Now, one of the things we're going to be doing is we're going to be finding the inverse of a function, and there is a process for this. Okay, the process is fairly easy. One thing I do want to point out before I talk through this is that not every function has an inverse that is also a function. And what happens is sometimes we're going to have to restrict the domain so that we can find an inverse. Here are our basic rules. I will get much more into this in a little bit. In general, you're going to change your f of x to a y. That's your first step. And then you're going to switch all of your x's and all of your y's. So everywhere there's a y, you write x. Everywhere there's an x, you write y. Now, once we've rearranged all of that, we're going to solve our equation for y. And then we're going to go backwards and change our y into f inverse of x. And we should have our inverses. Okay. So let's look at f of x is equal to 3x minus 1. First step is to change the f of x to a y. So this is y is equal to 3x minus 1. Now our second step is to switch all of our x's and y's. So this becomes x is equal to 3y minus 1. Now we want that y to be by itself, so I'm going to add 1 to both sides. X plus 1 equals 3y. Now divide both sides by a 3. And we have y is equal to x plus 1 over 3. And you're mostly done, but don't forget your last step is to switch it to an actual inverse. So where this y is, we write f inverse of x. And this is going to equal x plus 1 over 3. So that will be our inverse function. Okay, so let's try this one. My function is 2x minus 3 over x plus 1. First step is to change the f of x to a y. And now switch all of the x's and the y's so that I have x is equal to 2y minus 3 over y plus 1. Now we want the y's by itself, and so I need to get the y out of this denominator. So I'm going to multiply both sides by y plus 1. Now this is over 1 over here. This whole thing cancels out. So what I have right here is x times y plus 1 is equal to 2y minus 3. Let's distribute the x. xy plus x is equal to 2y minus 3. Okay, move up here. Now, we want our y's together because we're trying to get it solved for that. So let's just say, let's add 3 to both sides here and subtract xy right here. So I get x plus 3 is equal to 2y minus xy. Now, if I knew what this x were, I'd be able to combine like terms. But since I don't know, what I need to do is I need to factor the y out. So I have x plus 3 is equal to y times 2 minus x. Now I have a single y, which is what I wanted. So I'm going to divide both sides by 2 minus x. And I am just about done. I have y is equal to x plus 3 over 2 minus x. So I have my y by itself now, and then my last step is to change this y into f inverse of x is equal to x plus 3 over 2 minus x.